So right here in example 5, we have a cylinder, right cylinder. So in this case, it says a right circular cylinder has a height and a radius whose dimensions are changing. So again, keyword is changing right there. So the radius is growing at 2 feet per minute and the height is shrinking at 3 feet per minute. Find the rate of change of the volume of the cylinder at the moment the height is 10 feet and the radius is 8 feet. So we have a cylinder now, right? So a cylinder, again, you guys know how to draw a cylinder? Well, that's not how you draw a cylinder. All right. So we draw that. Okay. The best I could, pretty much. So the radius is changing. So the radius is right here. There's a little value right there at 2 feet, right? That would be dr dt is changing at 2 feet per minute. All righty. And then the height is shrinking. So the height of this dh over dt is shrinking. So that's negative 3 feet per minute. And then from there, so pretty much we're just going to do again. So we're given instances, right? The height is equal to 10 when this is happening, and the radius is equal to 8 when this is happening. So given is dh over dt. Again, that was equal to negative 3 feet per minute. And then we're also given the radius and how fast it's changing, which is dr dt, which again is equal to 2 feet per minute, right? That one's growing. So therefore it's positive. Okay. And then we need to find the rate of change of the volume of the cylinder. So dV over dt. And pretty much to find the volume of the cylinder, you just have to look up for the equation. Anyway, here it is. The volume is equal to pi times r squared times h, right? So here, pi is a constant. Don't forget that, right? And then r squared times h, we're going to have to use our product rule, right? So here we have r squared and then h. So this would be 2r times dr dt. And this would be just dh dt, correct? And then again, draw your fish. So this is equal to r squared times dh dt plus 2r times h times dr dt. All right, and then we do the substitution as always. So this is we're looking at r squared, which in this case happens to be 8 squared, and then dh dt is negative 3, so that would be negative 3 times plus 2 times r, which is just 8, and then the other one is the height, which happens to be 10. All right, and then we start simplifying again one more time, and then we end up with let's not forget about the pi right here, right? So that's the constant. So we got to make sure that one's attached to it. So I still have to multiply all of this by pi. Almost forgot about that one right there. So I was just focused mainly on doing the r squared, right, and times h. So here again, so dv dt is equal to, we simplify this again, grab a calculator. So that's going to be pi, right, times 320 minus 192, right? This was 192 plus 320. And that's going to be equal to our rate of change for the volume, which is 128 pi. And that would be, since it's volume, it's cubic feet per minute, right? And that would be dV dt. So the radius is decreasing at 4 feet per minute, and the height is decreasing at a rate of 2 feet per minute. So find the rate of change of the surface area of the cylinder at the moment the height is 10 feet and the radius is 8 feet. So again, we want to write our givens first. So in this case, they're saying that the radius is changing. So dr dt, right? Again, same picture as the previous one, right? The only thing that's changing are the parameters for dr dt, right? But everything else stays the same, right? Same height. R is 8, and then the height is 10. So dr dt is changing here, is decreasing at a rate at negative 4 feet per minute. And then the other one, the height is in this case is changing at a rate of 2 feet per minute. So that one's increasing, right? And then it says find the rate of change of the surface area. So we're looking for dA dt, right? And then to find the surface area of a cylinder, it's pretty much you add up the top and the bottom. So that would be 2 pi r squared. And then plus, if you were to unfold the pretty much like if you take a can apart, right, you get the other part, which would be, in this case, just 2 pi r h. All right. So we want to find our derivative from there. So to do that, we pretty much have to do just we do our first the first one, which would be, well, if you notice, you can factor out a 2 pi out of both of these. So let's do that. Maybe that'll make things simpler. So 2 pi times r squared plus r times h. Right. So here again, you want to take the derivative now. So that would be dA dt equals 2 pi, which is your constant, times the derivative of r squared, which is 2r times dr dt, and then plus you have to apply the product rule right here. So dr dt right here. This would be dh dt down here, and then draw your fish, right? So here plus that would be r times dh dt, and then plus uh, h times dr dt. All right, and then we want to start doing our substitution to figure out what dA dt is equal to. So again, 2 pi equals times 2r, which would be 2 times 8 times dr dt, which is -4, and then plus r, which again is 8, times dh dt, which is +2, and then plus h, which in this case happens to be 10, times dr dt, which is -4. All right, and then we keep simplifying that, and then we end up with 2 pi times -64 plus 16 minus 40. And then that's equal to, in this case, -176 pi, after you multiply it out, feet squared per minute.